Hi, I'm sorry that I can't be here today. I have jury duty, unfortunately. Hopefully, I will not get picked to be on a long standing jury, or if I do get picked, it'll be something short, and I'll be back here on Friday with you. Today, we're going to go over some notes continuing our discussion of points, lines, and planes. If you have not already, hopefully the substitute has given you the notes and we can continue from here. So, for today's notes, we're going to do some pieces of lines. We're going to start with something that's called a segment. Now, this particular way of writing a definition um, is something that some people really like, some people don't like it at all. I want to show it to you. Um, I have sheets like this in my room, so anytime we're taking notes, if you would like to do a definition on one of these, it's kind of nice because it has everything about it all in one place, and it's a little bigger than normally your notes would be, so it helps to emphasize it. So today we're going to look first of all at a segment. Some older textbooks call it a line segment, and you may have called it that in elementary school or something when you first learned about pieces of things. So the definition is a segment is a part of a line formed by 2 points, called the endpoints, and all the points between them. In other words, if you took a line and you just cut it in two places and took between the cuts, that's your segment. So again, remember that when we are naming points, always with a capital letter, here A and B. So this segment is point A and point B, and all the points that would be part of the line that would go through A and B. Remember, there's only one line that will go through A and B, so there's only one set of points that will connect A and B, and that's called a segment. What properties does a segment have? Well, two in particular. They're straight, just like lines, so you never have to say straight line and you never have to say straight segment. We only have straight segments. But unlike a line, which is infinite, this is finite. And I find that most students don't know the word finite. They know the word infinite, but not finite. Well, infinite means not finite. Finite means it has a beginning and an end. Infinite means no beginning, no end. So they don't continue on forever. So what is this a subset of? In other words, what does it come from? Well, that's a piece of a line. So we say that it is a subset of a line. What is it not the same as? And we'll talk about these a little later. It's not the same as array. How can you write that in symbols or abbreviations? It doesn't matter which of these two letters you put first. You write segment AB like so. It's an A and a B and a segment drawn above it, kind of like what we did for lines, except for lines we put arrows on the ends of them. Here, because these don't continue going, we won't. And I've had students in the past who sometimes, liked to put dots on the end of them. And that's fine. I won't do that because, well, it takes more time. And most textbooks don't anymore either, but some elementary textbooks do this kind of thing. So it doesn't matter whether you call this segment segment AB or segment BA. Either is fine. And let's rotate this back. There we go. Much better. So as I promised a second ago, the next thing we're going to talk about is array. And again, if you like the method on the previous page of taking these notes and you want to write this all onto a page like that, there's some up at the front of the room near the blue file folder holder on the far right on the table. If you would like to get one, that's fine with me. So a ray is the part of a line formed by a point, again called the end point, and all the collinear points to one side of that point. Remember, collinear means all on one line. So this is an example of a ray. Here's a point, all of the collinear points on one side of that. So again, rays are always straight, just like lines are. We never need to say straight ray. Rays are always straight. When we name them, we always name the end point first, and then we name one other point to tell the direction that it's going. So we could call this ray RS. What if it has more points than that on it? What if it also has a point over here, T? Doesn't change anything. I haven't changed this. This says the ray that starts at R and goes through S and then keeps going. Could I call it ray RT? Yep. It's the same set of points. If I start at R and I continue in a line going through T, I'm going to get S also. So either of those is fine. Also notice that even if a ray points to the left, we're always going to put the end point first, then the point that it goes through second. That's because we read from left to right. I suppose you could try and do this, but then what if you had an array that looked like this? Are you going to start drawing it like this is ray AB? It begins to get a little silly if you try to match that. So since we read from left to right, we'll always put the letters from left to right, end point, and then some other point on it. And again, it doesn't matter which. So we won't do it that way. We'll say ray AB or ray AC. Either one is fine. Notice the A has to be first though, because that's the end point of the ray. And as I said earlier, rays are straight and infinite, but only in one direction. Now, a plane is another figure we're going to use sometimes. It's a flat surface that has no thickness and it extends infinitely in all directions. The floor in this room is like a plane. It's flat, doesn't extend infinitely, and it definitely has some thickness, but it illustrates the idea of a plane. The ceiling the same. You know, the top of your desk is like a plane. When we're naming a plane, the easiest way to name a plane is if there is a capital, italicized, or script letter on the plane, we can just name it that. Notice this is not a point. Points will always be named with just a regular capital letter, not italicized or in script. So this is plain R. That's the simplest way to name this. We can also, though, name this by any three non-collinear points on the plane. So I could call it plane ABD because A, B, and D are not all on the same line. I could call it plane BCD if I wanted to. And it doesn't have to be alphabetical either. I could call this plane CBD. Oops, not CBC, CBD. It has to be 3 points if you're going to do it this way, and they have to be non-collinear. If they're all on the same line, it does not work. Now, one of the things that is most difficult to do is to draw something that is three-dimensional on your flat piece of paper. But we will do it sometimes. We're not going to do a lot first semester, but we will do more second semester, especially when we get to things like cylinders and pyramids. So here we have a picture of a line that is intersecting a plane at a single point. Now, what does this look like in real life? Well, plane P, imagine it is the top of your desk. And lines XQ, or you could call it XZ, or you could call it QZ, and line WY, or WQ, or line QY, are drawn on your desk. So some naughty person got out a Sharpie and drew those on the desk. But what about this line, and why is it dotted here? Well, this line, line AB, or I could call it line AX, or line XB, is going through the plane. So this would be if you could take your pencil and hit your desk hard enough to where the pencil shoved through the desk. The reason that it is dotted here is because you cannot see the line. If you shoved your pencil through the desk, please don't try it, by the way. If you did it though, there would be, if you're standing above the desk, there's part of it you can't see. Now, if the pencil were long enough, eventually you'd be able to see it again. And that's what's happening here. This line, line AB, is intersecting the plane. The line only actually touches the plane at point X. Point X is on the desk in the plane and on your pencil. It's on the line. It's in both. That's why it's called an intersection. An intersection is something that belongs to two different groups. So X is the intersection of line AB with plane P. So we say line AB intersects plane P, and line XZ also at X. X is a part of all three of these. Notice, though, that line AB does not intersect line WY. Notice this dotted line means that this is behind, or in this case, below the plane, whereas WY, since it's drawn with a solid line, is on the plane. So this is on the desk. This is below the desk. So WY is all on P. Line AB only touches plane P at X, and that's not a point on line WY. Looking at the other two lines, line XZ and line WY, they're both on the plane. They're drawn with solid lines within the borders of this plane, and they intersect each other at Q. So we say that they lie in the plane or on the plane. The preposition really doesn't matter. They intersect at Q. Now, if two planes intersect, their intersection is a line. So, this diagram is meant to illustrate something like a box. Think about a shoebox, for example. Plane M is the top of the shoebox. Plane R is one of the sides of the shoebox. And again, remember, a plane actually extends infinitely in all directions. It doesn't stop like the box does, but the box is a pretty good illustration here. The points that are on both of those planes are the intersection. So here, all these points along here are both on plane M or in plane M, if you will. Either one is fine. And they're also on plane R. They're part of two different groups. So if we connect all of them, we get this. And someone will say, well, isn't that a segment? Well, in the box it is, because your box is not infinite. But remember, we can't draw this infinitely, so we just drew these figures to illustrate the plane. They keep going, and so the intersection would keep going as well. If you want to see an illustration of this in the room, just look up at the very front of the room. You'll see that there is a place where the wall meets the ceiling, and it forms a line. Where the wall and the ceiling meet, any point that's both on the wall and the ceiling makes a line. Actually, in the classroom, it makes a segment because it doesn't go on forever, but it illustrates this idea. Okay, your homework, of course, is posted in both RenWeb and on Google Classroom. And it is, hang on just a second, out of your textbook. Be sure that you're in Chapter 1 in Section 1.1 of the textbook. I'll look forward to seeing you on Friday. Have a good day.